Fractions and decimals. In this chapter, we are going to learn about fractions and decimals. First, let us see what is a fraction. Say, for example, here is an apple. If this apple is cut into two parts, we say this apple, one apple is made into two parts. Now each part is called 1/2, a half. So this is a fraction. So what is a fraction? A fraction is a part of a whole or a group. That is called a fraction. Now let us see some more examples of fractions. These are some examples of fractions. Now how do we read a fraction? Here 3/4. How do we spell it? We call it as 3/4. 3/4. And 5/12. How do we spell it? 5/12. And 1/3. We call it as 1/3. In this way, we spell the fractions. See, every fraction has two values. The top one is called as numerator. Numerator. And the bottom value is called as denominator. Denominator. So here 3 is the denominator, 1 is the numerator. 5 is the numerator and 12 is the denominator. 3 is the numerator and 4 is the denominator in these fractions. Now let us see the types of fractions. So fractions are of two types, proper fractions and improper fractions. Let us see what is a proper fraction. A proper fraction which is less than 1 and is a part of a whole. In a proper fraction, the numerator is always less than the denominator. So such kind of fractions are called as proper fraction. See here 1/6. The numerator is less than the denominator and this 1/6 is smaller than 1. So it is a part of one whole. So this fraction, it doesn't represent a group for one thing, only one object. So here 1/6 is a proper fraction. Now what is an improper fraction? In improper fractions, the denominator is less than the numerator. So the numerator is having the higher value. 3/2 is an improper fraction. 3/2. Now let us find out which are the proper fractions and which are improper. 7/3. So 7/3, 7, numerator is the higher value and 7/3 is an improper fraction. And here 1/3. 1/3 is a proper fraction. 5/2. 5/2 improper. Why it is improper fraction? Because the numerator value is bigger compared to the denominator. So 1/10. 1/10 is a proper fraction because it is less than 1. 1/10 is a part of 1. And even the numerator is having less value than the denominator. So this is a proper fraction. So the next one, 8/2. It is an improper fraction because the numerator is bigger than the denominator. So now we understood what is a proper fraction and what is an improper fraction. Now let us see the mixed fractions. So what is the mixed fraction? Say for example 5/2. So what is there in this 5/2? Now let us learn about mixed fractions. So what is a mixed fraction? We know that the value of an improper fraction is greater than 1. Say, for example, 5/2. If we represent this 5/2 fraction in the form of a picture, it will have two wholes and a half. That means 5/2 means 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2. So it is having 5 1/2s. That is 1/2, 2 1/2s, 2 1/2s. So that is here half half, one whole and half half, another whole and half. So it becomes 2 plus half, 2 and a half. So this is a mixed fraction. So 5 by 2 can be written as 2, 1 by 2. This is called a mixed fraction. Fractional numbers on the number line. We can show the fractional numbers even on a number line. See here, 1 by 2. How to show this 1 by 2 on a number line? So let us look at a number line. Here is 0, here is 1. Now, where we have to locate this 1 by 2? We know 1 by 2 is a proper fraction. 1 by 2, it is half of 1. That means this is less than 1. And it stays between 0 and 1. So 1 by 2's position is between 0 and 1. So 1 by 2 is greater than 0 and less than 1. 1 by 2 is greater than 0. And 1 by 2 is less than 1. That means it is lying between 1 and 0. So this 1 by 2 lies at equal distance from 0 to 1. So equal distance at the center point between 0 and 1, we can locate 1 by 2. Now let us locate 1 by 3 on the number line. So we are going to mark 1 by 3 on the number line. This is also a proper fraction. 1 by 3 means 1 made into 3 parts. So 3 parts. This unit must be made into 3 equal parts. Okay. So this is the first part, second part, third part of 1. So here we write 1 by 3. And here we write 2 by 3. This is 3 by 3, means 1. So this is 1 by 3. In this way, we can mark even fractions on a number line. Let us see one more example of representing a fraction on a number line. Here we have to mark 1/5, 2/5, 3/5 and 4 by 5, 4/5 on a number line. So this is 1 and this is 0. To mark these fractions on number line, the gap between 0 and 1 should be made into 5 equal divisions. 1, 2, 3, 4, 5. Now the first one becomes 1 by 5, that is 1/5. Second one becomes 2/5 and third one becomes 3/5 and fourth one becomes 4/5, and this is 5 by 5 part 1. So in this way we can mark fractions on a number line. Equivalent fractions. Here are the representations of some fractions. Let us see the first one. Here is a picture representing a fraction 1 by 4, 1/4, and here is a fraction total 8, 2, 2/8, and here is a fraction total number of cells 12, 3/12, and here is a fraction total cells 16, 4/16. If we observe these fractions closely, we find one similarity. See, this is 1 by 4. If you see this fraction, both the numerator and denominator are divisible by a number. What is that number? 2. Say 2 1s, 2 4s. That means this also becomes 1/4 in simple form. Here 3/12. This numerator and this denominator is also divisible by one number, that is 3. So 1/4. In simplest form, this also becomes 1 by 4. And if we go to the next one, here this numerator and denominator are divisible by 4. 4 1s, 4 4s. So in simplest form, all these fractions are of same value, 1/4. So this kind of fractions are called as equivalent fractions. Now let us see how to write equivalent fractions for this 1 by 3. To write an equivalent fraction for a fraction, we have to multiply its numerator and denominator with the same number. Here we can write 2 by 6. For example, with 2 we multiply 2 ones 2, 2 3s 6. We can write 3 by 9. So this 1 by 3 is multiplied with 3. 3 ones 3, 3 3s 9. 4 by 12. 5 by 15. So in the simplest form, all of these fractions becomes 1 by 3. 1 by 3, and this 2 ones, 2 3s, 1 by 3. Again with 3, if you divide it with 3, it becomes 1 by 3. So all these fractions simplest form 1 by 3. In this way, we can write equivalent fractions. Lowest form of a fraction. Here we have seen these equivalent fractions. 1 by 3, 2 sixths, 3 ninths, 4 twelfths, 5 15th. All these are multiples of this 1 by 3 or 1/3. So here these are all not the standard form. See, if you find out the simplest form, both the numerator and denominator both are divided by one number. They are divided by 2. Here they are divided by 3. Here they are divided by 4. So these are not the standard forms because they can be made into the simplest form. If you try to make it into simplest form, it becomes 1/3. It becomes 1/3. If you divide with 4, it becomes 1/3. If you divide it with 5, it becomes 1/3. So here 1/3 is the standard and simplest form of all these fractions. So these are not the standard fractions. So their least form, their lowest form is 1/3. But there are some fractions, see 2 by 3. This is the lowest form. This is not having any other simplest form because either the numerator or denominator, they are not divided by any common number. So they don't have any common factor. So 2 by 3 is not having any common factor. Even 7, 3, 7, 3. 7 by 3 in this 7 and 3 are not having any common factor. So here this one 17 by 7, it is not having any common factor. So these are the examples of lowest forms of fractions. Comparing unlike fractions. Here we have two unlike fractions. We have to compare these fractions and tell which is bigger and which is smaller. In case of a like fraction, the denominators will be the same. So it is easy to find out which is bigger and smaller just by looking at it. Now here both are unlike. So we cannot just tell it whether which is bigger or smaller just by looking at them. So what do we do now? Here, to compare these unlike fractions, first convert these unlike fractions into equivalent like fractions. So see 2 by 3. 2 by 3 into 5 by 5 equal to 2 5s 10, 3 5s 15. So the second one 3 by 5. 3 by 5 into 3 by 3. 3 3 is 9, 5 3 is 15. So 2 by 3 became 10 by 15. 9 by 15 is less than 10 by 15. That means 3 by 5 is less than 2 by 3. Ascending and descending order. We know what is ascending and descending order. When we write the numbers from smaller to bigger, from left to right, we call it as ascending order. That means it goes on increasing in value. 1, 3, 6, 8, 10. Now we say this is an ascending order because 1 is less than 3, 3 is less than 6, 6 is less than 8, 8 is less than 10. In this way. So the same applies even to the fractions. Even the fractions, if they are written from smaller to bigger fraction from left to right side, we call it as ascending order. If you do that in reverse, you call it as descending order. Let us see some fractions in ascending order. Let us see here some fractions. 2 fifths, 3 fifths, 7 fifths, 16 fifths. So here the value is increasing from left to right. Here this 2 fifths is less than 3 by 5. And 3 by 5 is less than 7 by 5 and 7 by 5 is less than 16 by 5. So this is the increasing order. So we call this as ascending order. So here these fractions are in ascending order. In the same way, 1/7, 1/6, 1/5, 1/4. So these are also in ascending order. 1/7 is less than 1/6, 1/6 is less than 1/5, and 1/5 is less than 1/4. So these are also in ascending order. Now let us see some fractions in descending order. Here are some fractions which are in descending order. 11/2, it's greater than 7/2, it's greater than 5/2, it's greater than 3/2. So this is in descending order. In the same way, 1/4 is greater than 1/5, is greater than 1/6, is greater than 1/7. So these fractions are also in descending order. Addition of fractions. This picture represents 1/4 and this picture represents 1/4. Now we're going to add this 1/4 plus 1/4. 1/4 plus 1/4 gives rise to 1/2. In the same way, this picture represents 1/2 and this picture represents 1/2. So 1/2 plus 1/2, half plus half, it gives 1. So this is the addition of fractions. Adding unlike fractions. We have seen in the previous example, if the fractions are like fractions, say for example 1/2 plus 1/2, these two are like fractions. In case of a like fraction addition, the denominator remains the same because in both the cases the same number, the denominator we keep the same and the numerators are added. 1. So this way we do the addition of a like fraction. Now let us see how to add two unlike fractions. Let us take 1/2, 1/3. Now this 1/2, 1/3, these two are unlike fractions. So we cannot add these two fractions. We cannot add the numerators here because the denominators are different. So what do we do now? Now we have to convert these unlike fractions to like fractions. Say 1/2 is equal to 1/2 into 3/3, 3/6. In the same way, 1/3 equal to 1/3 into 2/2 is equal to 6. So now 3/6, 2/6. Here we got 3/6 plus 2/6. So both these fractions 1/2 and 1/3 are converted to like fractions now. So 3 plus 2, 5/6. So the addition of 1/2, 1/3, 5/6. So in this way we can carry out the addition of unlike fractions. Now let us see the addition of mixed fractions. Here we have two mixed fractions. Now we will see how to add these two fractions. In one way, first we can convert these mixed fractions into improper fractions. 2 into 3, 2 3 6 plus 1 7/3. So the improper fraction of this 2 1/3 mixed fraction is 7/3 plus 1 3 is 3, 3 plus 2 5, 5/3. So here the denominator is common. Now 7 plus 5, 12, 3 4s 12. So here the answer is 4. But here we have one more method to add two mixed fractions. Let us see how to do it. Now let us see the second method. First we will add the numbers, then we will add the fractions. 2/3. So here 2 we have taken here, 1 we have taken here, 2 plus 1 plus 1/3 plus 2/3. Now 2 plus 1 it becomes 3 plus 1/3 plus 2/3. Here the denominators are same denominator. The numerator 1 plus 2, 3. So now 3 3 1, 3 plus 1 4. Now let us see the subtraction of fractions. Here we have two fractions, 4/7 minus 3/7. Let us see how to do this subtraction. Here the denominators in both the cases are same. So these two fractions are like fractions. So 4 by 7 minus 3 by 7. That means from 4 1 by 7s, 3 1 by 7s are to be removed. 7 is a common, the denominator. 4 minus 3, 1 by 7. So in this way we can do the subtraction of a like fraction. Now let us see the subtraction of 3 by 10 minus 2 by 9. Can we do this subtraction just like the before example? No, it's not possible. In the previous example, both the fractions were like fractions. Their denominators were same. But here, these two are unlike fractions because their denominators are different. Now let us see how to do this subtraction of these unlike fractions. First, we make these unlike fractions into like fractions. 3 by 10 equal to 3 by 10 into 9 by 9. 3 nines, 27 by 90. Now let us take 2 by 9 equal to 2 by 9 into 10 by 10. 2 tenths, 20 and 9 tenths, 90. So now the denominators are same. So that is 3 by 10 minus 2 by 9 equal to 27 by 90 minus 20 by 90 equal to, the denominator is same, 27 minus 20 equal to 7 by 90. So this is the answer. In this way, we can do the subtraction of two unlike factors. Decimals. Let us understand decimals with the help of an example. See, here we have a fish. We would like to measure the length of the fish. So, we use a scale to measure the length of the fish. Here, this is a scale which is having 15 centimeters graduated on it. So, we place the fish at the 0 to find out its length. Now, the length of the fish has come to 4, but it's not exactly 4. It is a bit more than 4. So, you cannot write it is 4 centimeters because it is more than 4 centimeters. And it is not even 5 centimeters. So, it is more than 4 but less than 5. Now, how do you give its exact or accurate measurement? We do one thing. Now, let us divide the space between 4 and 5 into 10 equal divisions. So, we made this 10 equal divisions. Now, we draw a line. So, it came till 4 centimeter, then 2 by 3 of the 10 divisions. So the length of the fish becomes 4 2 by 3 centimeter. Now let's see the length of this pencil. It is more than 3 centimeter and less than 4 centimeter. So we divide this area into 10 equal divisions. So now let us see. Here, out of these 10 divisions, the pencil is having 3 centimeter length and plus 5 divisions out of 10. So 5 divisions out of 10. 3 5 by 10. In the previous example also, where we measured the length of the fish, 4 2 by 10. So that is the measurement. So here 3 5 by 10 is the measure. Now we can write this fraction in the form of a decimal. Let us see. 5 by 10. 5 by 10 is equal to 0.5. So now 3, you can write 3.0 plus 0.5. That means 3.5 centimeters. Instead of writing 3 5 by 10, we can write 3.5 centimeter. In this way, we can express the fraction in decimals.